All right, you SL1 fans, you're back with Mr. Jolly. Today we're going to be talking about 2.3. This one, we're going to talk about graphs. So, if you could have your notes out, please write down everything I'm writing down, or at least, jot down the general ideas. That'd be great. A lot of the stuff we're going to talk about today you probably have seen before. So, most of it's a refresher. I think there's maybe one thing that you haven't seen, but let's check it out. We're just going to jump into it with some examples. So, first example, draw the graph of each line. So, sketch each graph. And I'll talk about what a sketch of a graph should look like, what the important parts are. The first one, x-intercept. So the x-int is at -3, 0. It's a negative. I'm going to undo that. So, I got all the way back. Man, I'm killing it already. -3, 0, and y-intercept at 0, 5. So the y-int is at 0, 5. That 0 is bad. I promised I would do better, and I'm going to do better, guys. Okay, for this one, I always start with my x and y axis if I'm going to sketch a graph. So here's the good old x on the horizontal, the good old y on the vertical. X-intercept is at -3, 0. So I would just count over 3 spots. Here's -3, 0. Label it if we want. And then the y-intercept is at 0, 5. So that means you don't go anywhere on the x direction, and then you go 1, 2, 3, 4, 5 up on the y, and then you connect them with a straight line. Oh, watch this. You're like, oh, that line doesn't look very straight, Mr. Jolly. Oh, boom. Yeah, right there. Got it. I should label that since I was labeling. And that's things to say about that graph. It has a positive slope. It's going uphill as you read it left to right. Remember, you read graphs from left to right, so if I go from the left to the right, I'm walking uphill. Positive slope. Next up, let's see. Y-intercept at 0, -1. And this one has a slope of 1/2. Ooh, I'm going to say right now is a perfect opportunity that your book sometimes will refer to slope as a gradient. This is something that we don't really say in the United States. Oops. Forgot to spell Jolly. Gradient. We don't say that too often, but it's a British thing. So if you hear the word gradient, they just mean slope. Don't, shut down. Okay, for this one, we know where it crosses the y-axis. Let's go back to my orange here. Let's put out my axes. Here's the x, here's the y. We know it crosses at 0, -1, which is right here. So 0, -1. Now the slope of 1, 2, just a reminder that this is a rise over run. So here's your rise and here's your run. That means for every 1 that you rise, that we are going to run 2 in a positive direction. So that's vertical over horizontal, rise over run. So if I just count good old-fashioned blocks, if I go up 1 and then over 2, that would be this point right here. So here, I'll get a little zoom on that. That means I went up 1 over 2. So it's 1 up, 2 over. And then I could do it again. You go up 1 over 2. And I don't know if you've had teachers in the past that are like, you have to do at least 3 points or blah, blah, blah. And you have to, you could, instead of going up 1 over 2, you could go back 2, down 1. You could go this way, back 2, down 1. But you guys see how these are all forming a line? Close enough. Just make the dots thicker. That's how you fix that. Another positive uphill slope. Well, that makes sense because we had a positive slope from the beginning. Cool. Beautiful sketch. Well done. Next up. A good old-fashioned y equals mx plus b. Y equals negative x plus 1. Just a refresher, this is a y equals mx plus b, where this guy is your slope or gradient, and this guy is your y-intercept. So, in this case, our slope equals negative 1, and the y-intercept is positive 1, is 0, comma 1. So if I go back to my orange and start sketching a graph, here's my x, here's my y. I know it crosses at 0, positive 1. Now, if you're looking at this slope right here of negative 1 and you're like, I'm not sure what that looks like, remember that every slope is a rise over run. So you can really think of that as negative 1 over positive 1. You can always turn it into a fraction if you need to. So your rise over run means that for every negative 1 that it rises, it runs positive 1. So it goes down 1 over to the right 1. So if I go back to my dots, that means down 1 over to the right 1, down 1 over to the right 1. And then you can just kind of connect those dots. I think 3 is definitely enough. Let's see if I can get the line. Boom. Nailed it. Ooh, our first line with a negative slope. This goes downhill as you read it from left to right. So that's a negative slope. Cool. So that was the methods we've done graphing. Like you can graph with the two intercepts and connect them with a line. You can start with a point on the line and then use the slope to find more points. Or you can use the y equals mx plus b, which is very similar to this method. And then the third method, which is actually kind of my favorite, depending on how they give you the equation, is something like this. If you were to sketch c of n is equal to 40 plus 5n. Clean that up, Jelly. Okay, first of all, you're looking at a y equals mx plus b, where the slope would be 5 over 1 and the y-intercept would be 40. You can do it that way, but I think this equation lends itself to just graphing by intercepts. So here's what we're going to do. To graph by intercepts, we are going to replace n with 0 to find the y-intercept, and then replace this whole part with 0 to find the x-intercept. Kind of wish that they hadn't used those letters, but oh well. So first let's find c of 0 is equal to 40 plus 5 times 0, which is equal to 40. So that means that the x, because I replaced the x with 0, that the x-intercept, no, sorry, I replaced the x with 0 to get the y-intercept. So the y-intercept is 40. So y-int is 0, comma 40. Because I put in a 0 and got out a 40. To find the y-intercept, you do the opposite, where you, instead of putting 0 into the function, you make the 0 out of the function and try to solve. So 0 equals 40 plus 5n. Subtract 40 from both sides. Divide by 5, and you get negative 8 is equal to n. So this means that the x-intercept is negative 8, comma 0. This means if you put a negative 8 into the function, you get out a 0. Now that I have those 2 points, I think this is sufficient to make just a beautiful graph. So, well, pretend that that's level. This is going to be your n, and this is your c of n in this case. Or you can think of it like x and y. X-intercept is negative 8, comma 0. So let's say that that's, I don't know, around here. And then the y-intercept is 40. So we'll say that's up here somewhere. And then connect them with a line. Close enough. positive slope uphill. The last thing that they want you to do in this section, it's a pretty small section, is using your GDC, so graphics display calculator. You're going to hit that y equals button in the upper left-hand corner and punch in these equations. So the first one is, using your GDC, sketch a graph. So the first one, f of x is equal to negative x squared plus 4. You may be able to kind of already tell what this is going to look like. Like if I just throw an x squared up here, do you guys automatically know that that's a parabola? And then because of the negative outside, it got turned upside down. And then because of this, it got shifted 4 up. It's okay if that went way too fast and you're like, I don't remember that, Mr. Jelly. We're going to have a whole section where we do stuff like that. But since they're like, yo, just use your graphing calculator, I'm not too worried. You can just literally graph it and then sketch it on your page. So, looks something like this. Upside downy parabola. The top, the vertex is at 0, 4. From your graphing calculator, you can figure out these are 2, 0 and negative 2, 0. Next up, last one, still using your GDC. So part B, graph y equals the square root of x minus 3. Now, some people might look at that and be like, oh yeah, I remember this. The square roots, they always look like a dolphin kind of jumping out of the water at the top of the ocean. And that minus 3 means that it was pushed 3 to the, is it the left or the right? Oh, it's the right because it's backwards. At any rate, don't worry too much about that. We're still using a graphing calculator, so crunch, 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 y equals, hit enter. You can see that, let's go back to orange. This does look like a dolphin jumping out of the ocean. Right here at 3, 0. And then it goes, it's like half a sleeping parabola. All right, guys, that's all I got for you. Homework is right below this video.